Good morning, sir. I am excited to present our project, which is cloud-based multimodal language processing system. Myself, Ravidas, along with my teammate Paki and Preeti, developed this project under the guidance of you, sir. The problem with traditional tool is that it generally focus on just one types of data. Either it will be text, audio or image. For example, if you upload an audio clip to a text only translate, it won't understand your content without first converting it to text. Or if you upload a photo to a text-based application, it cannot describe what is the image. So to solve this limitation, we aim to develop a unified cloud-powered platform. Our goal was to integrate advanced AI technology capable of handling text, speech, and image processing simultaneously and seamlessly. This integration solution can instantly translate spoken language into text, generate accurate caption describing visual scenes, convert textual information into clear natural speech. So our ultimately objective is to create a multimodal tool that break down communication barrier, enhance accessibility for all users and deliver a smoother, richer interaction across different language and data formats. So, our multimodal language processing system has real-world impact across various practical scenarios. For example, a student learning French who struggle with pronunciation. With our system, they can upload French audio clip, instantly transcribing them into a text to a practice pronunciation. Or they can input phrase in English and immediately hear accurate translation spoke in French. So other example, consider a visually impaired person navigating everyday situation. So our image captioning enable user to understand their surrounding better by only uploading a picture and receiving instant audio description. Text-to-speech conversation make them easier to access email, message, and written content effortlessly. So another example, themes of content creator managing a global audience. So our system automatically transcribe podcast into text, instantly translating transcript into multiple language, expanding global reach effortlessly. It generates automatic caption for image, streamlining content creation for website and social media platform. So by integrating text, audio and visual processing, we significantly enrich user experience across diverse applications. So deploying our multimodal system in the cloud has provided significant advantage that directly translate into better performance and user experience. Like scalability, which handle varying workload whether there are 100 users or 1,000 users. Second, enhanced security. The cloud offers robust security measures protecting our sensitive user data and media input. Third is operational efficiency. Cloud infrastructure automatically manage backend resource, eliminating monotonous manual tasks. Third is consistent execution, means every update of deployment behave consistently, minimizing unexpected issue, thus ensuring reliability across the different user sections. So main question is how we have deployed our multimodal on the cloud. We deployed our front-end using Netlify, which provide automatic build, global CDN support, and serverless function. For our backend, we choose Render, a platform offering built-in CI/CD pipeline, auto scaling, and global infrastructure. This combination guarantee high availability of resource and better optimization. Overall, this diagram represents how our web application is deployed in the cloud using Netlify for the front end and Render for the back end. It also highlights automation, secure communication, and how everything works together to deliver a seamless user experience. So our projects utilize the following technology layer: front end, React.js with JSX, hooks, and form; back end with Flux, Python, Reset API, which ensures secure and smooth data flow between the front end and back end; cloud API, Google Cloud, STT, TTS, and translation service, which enable core functionality like real-time speech-to-text transcription, natural voice generation; ML model, Hugging Face VIT, GPT-2 for image captioning. Other library like GTTS, Google Trans, Speech Recognition, Transformer, PyTorch, file, etc. These libraries handle audio conversation, language detection, speech recognition, and model execution efficiently. So from here, Preeti will explain the further part.
So starting with the system architecture, this is the visual representation of the system architecture. First is front-end interface. It is built with the React.js. The front-end allows the user to submit text, audio, or image inputs through an interface. This handles real-time interactions such as uploading files in format of JPEG or MP3 and sends requests to the backend for processing. Next is input handler. The Flash-based backend acts as a central router, receiving requests from the front end and directing them to the appropriate module. Next is text analysis module. Leveraging Google Cloud's natural language API, this module extracts sentimental scores from -1 to +1, identify entities, people or location, and paraphrazes syntax from the input text. Next is response synthesizer. It combines process data from other modules to generate user-friendly outputs. For voice responses, it uses Google text-to-speech and convert into natural-sounding audio in MP3 format. Next is image understanding module, powered by Hugging Face BLIP module. This component generates contextual captions from the images. It processes JPEG or PNG files in less than 3 seconds using GPU acceleration. Next is speech processing module. This module uses Google Cloud's speech to text API to convert spoken input and analyzable text. It supports 125 plus languages and also provides transcriptions with the timestamps. Next is feedback capture module, collects user rating and error reports to improve system performance. This data also trains future model updates such as refining translation or underrepresented languages or optimizing image caption accuracy. Next is workflow of the model. First, the process begins when user interacts with the system via interface. Next is user interface. User inputs the text, upload images or audios, or clicks on the button. For example, typing hello for translation or uploading a voice note. Next is user translation. A user enters the text for the translation or adds the audio in MP3 format or images in PG or PNG format. Next, clicks on the button, triggers actions like translate or generate captions. Next is API request. The front end sends requests to the backend, like example sending hello to be translated in French. Flash backend. It receives requests and decides where to be sent. Images are sent in Hugging Face AI and text or audio in Google's Cloud API. It also checks for the errors. Processing Hugging Face model generates captions for images. Next, Google Cloud's API converts text between 100 plus languages, speech to text and text to speech. For example, changing, for example, bonjour French text is being translated. Response handling, simple sent as a simple message in JSON format. Displays result. The front end output shows translated a text in a box, audio player for the voice result, image caption below the pictures, error handling. So next is the core features. Uh, there are three core features: text translation, speech services, and image captioning. In text translation, it detects input languages, translate text in less than 500 milliseconds, and supports 100 plus languages. Speech services are it translates from speech to text and text to speech. As we can see, 92% accuracy is provided in speech to text. And also there is 200 plus natural sounding voices in text to speech. Using image captioning, we use BLIP model captioning captions like a group of.
So now let's explore the core services of our multimodal language processing platform, now live with the front end on Netlify and the back end on Render. So all the services connect via access HTTP request, running in real time using cloud APIs or deep learning models that are hosted on Render. So these are our services. So moving to the first service, which is the text service. So it combines the translation and the text to speech conversion. It auto detects the input language, translates it to the target language according to the user, and converts it into speech using Google text to speech. So this is the workflow of text service. So first user enters the text input, and then the detected language appears on the screen with the confidence score, and then the detected language. After the detection of language, it can be translated into any of the languages according to the as per the user, and then the translated language is converted to speech using Google Cloud text to speech API, and the audio is played using MP3 playback. So the cloud API is used are the Google Translation API for accurate multilingual translation, and GTTS for fast diverse voice synthesis. The next service is the speech to text. This module transcribes uploaded audio and optionally translates it. So this is the workflow. The user uploads the audio, and then the audio is converted into text using speech to text API, and then it can be translated as per the language entered by the user, and the translated output appears on the screen. So Google speech to text API is used for accurate noise resilient transcription in multiple languages. The image captioning, it is the most exciting feature, and in this feature, the user uploads an image and our model generates human-like captions. So the workflow is as follows. The user uploads the image, and then the blip hugging face transformer uh, sees the learns the image features, and the caption is generated using the GPT-2 transformer. So model details are blip extract visual content, and GPT-2 generates fluent captions and hosted on render for scalable GPU or CPU usage. So now let me show the live demo. So our React.js frontend on Netlify ensures smooth UI UX and the fast backend on render process request using model and the cloud APIs. This is a React.js frontend hosted on Netlify. Let me enter. So here we can see that the language detected is English with a confidence score of 1. Now we can translate it into any of the language. And here we can see the translated text. We can convert the translated text to speech.
सबको सुप्रभात।
Now for speech to text, we can choose the audio file and the transcribed speech will appear on. We can convert the transcribed speech into any of our language, for example, German. And here is the translated speech in German. Now for the image captioning. This is the image that we have uploaded, and now we can generate. So here we can see that the caption is generated according to the image, and it says that there are two giraffes that are standing next to each other. Similarly, we can upload image in any format like JPG, PNG, etc., and audio files also in MP3 or WAV format, and the desired features will work. And so the React.js frontend on Netlify ensures smooth UI UX, while the Flask backend hosted on Render request using models and cloud APIs. So this is the backend which is hosted on Render. Each user input, whether text, audio, or image, is handled in real time, delivering results with speed and precision. And here is our code. So this is the code, and there are three main files. App.py supports the backend. So this is the app.py, and the app.js and app.css supports the front end. This is the sample output of our entire UI. Here we can see all the services: text service, speech to text, and image captioning. And these are the sample output for individual services. Now moving on to the performance highlights. So fast and responsive, the text translation and text to speech takes less than 0.5 seconds, and 1 to 3 seconds are taken for the image captioning. And for speech to text, real time transcription takes less than 30 seconds for audio clips with 85% accuracy. Blip models, moving on to accurate AI output. So Blip model generates context-rich captions, and speech-to-text maintains 85% accuracy even in noisy environments. Google Translate preserves idioms and context. Multilingual capabilities. So our AI assistant supports 100 plus languages for text and speech, including all the regional languages like Hindi, Tamil, Bengali, etc. Real-time audio playback, translated text to speech played instantly, and it auto deletes the temporary files to optimize the storage. It consists of a responsive UI. React.js single page app ensures seamless interaction and instant feedback for every input type, text, audio, or image. And at last comes the most important part, the hybrid Cloud Edge Hybrid, which combines the Google Cloud APIs and local ML for efficiency and control, and it is optimized for scalability and cost-effective deployment. So now moving on to the conclusion of our project. This project combines Google Cloud APIs with locally hosted ML models to build a real-time multimodal AI assistant capable of translating